The BLK360 can be used for a wide variety of tasks where it will excel at the majority of them. However, there are a few items or surfaces that can be challenging. This all comes down to two things when dealing with a laser. The first is mirror-like surfaces, which just redirects the laser off what you're trying to scan, and the second is reflectability, which the laser scanning industry knows it as albedo. If you look at the specification sheet of any laser scanner on the market, chances are you will see this term albedo as it relates to the maximum range, or how far the instrument can scan, and or how accurate the instrument measures a distance, known as the ranging accuracy. As a note, this is not to be confused with 3D positional accuracy, as that requires the angular accuracy of an instrument as well. To put things into perspective, the average reflectability in the world is about 30%. This equates to a dark gray color. With that said, we will cover 4 challenging surfaces that you may encounter. The first is a dark matte surface. Second, reflective surfaces, like this cooktop. Third, mirrors. And last, shiny cars. In the case of dark matte or black matte surfaces like coal or this rubber flooring, the reflectability is very low. This means that laser energy or light is mostly absorbed, which makes it hard for a scanner to quote see it. If you scan this type of surface, the resulting scan may look something like this. One tip may be to apply small pieces of tape in strategic locations so that you can properly capture the surface. Always remember that you will still get more information off the surface, even with the tape applied, than had you measured it with conventional tools. As you can see from the scan, the tape markings show up nicely because they are a higher reflectability or albedo, which makes it easier for the scanner to quote see. Next is reflective surfaces like this cooktop. When trying to scan something like this, the laser will just reflect right off the surface, where the laser will not get any kind of return. There are 2 tips for something like this. Like the dark matte surfaces, apply tape like masking or painter's tape to the edges so that you can define the surface while modeling. In this case, the scan will look something like this. The other is to apply some sort of powder to the surface like talcum powder. This will make the surface reflective for the scanner and you will be able to get data off the surface. If you use this method, the resulting scan will look something like this. Once you're done, just wipe off the powder and you'll be back to what it was. Next is mirrors. No laser scanner on the market is immune to this challenge. Mirror surfaces just cannot be scanned. However, when looking at data where a mirror is present, it will actually appear that there is data. This is actually the reflection of the laser onto a different surface. In this case, the data in the mirror is of the towel rack and clock on the adjacent wall. However, the data in the reflection will be in a straight line because the laser distance will be calculated by using the distance from the scanner to the mirror plus the distance from the mirror to the reflected surface. If you do have mirrors in your scans, it is best to delete out the data where mirrors are because they can make registrations a bit more tricky. With all that said, there may be some projects where you just need to scan a surface of a mirror. One tip is to put masking tape or painter's tape on the mirror surface so that a plane can be established on the surface. The resulting scan will look something like this. Notice the reflected data where the tape isn't. If we were to go into the software and take a look at the data, we can zoom in, rotate, and you'll notice that the data has been projected in a straight line from the scanner. This is as we have described earlier in this video. Also, it is best to delete this data because it could be problematic in the registration. We'll simply dispense it and remove it from the scan. Now we have a nice clean data set. Also, you can see from the tape, you now have the surface of the mirror. Last is scanning cars. When scanning cars, you need to keep in mind on how to tackle both the color and a mirror-like surface. This is where it's most evident where not every scanner is made alike comes into play. This is because most of your higher-end professional-grade scanners will have an easier time with surfaces like these since the laser system is built very different. However, here are a few tips to be aware of when scanning this type of surface. Cars that have just been through a car wash and or are wet can be challenging because the body of the car is shiny. If you remember back from the cooktop example, the laser will just reflect off the surface, resulting in a void in the scan data. Furthermore, in many cases, shiny black cars can be the Achilles heel for many, not all, scanners that are in the market today. With some scanners, you may get a result that looks like this. Remember, in the case of the black car, the albedo of the surface is extremely low, so you need to help the scanner out. One tip is to apply a powder like talcum powder so that we can increase the reflectability or albedo. As you can see here, the car was lightly dusted and the resulting scan looks something like this. Also, as mentioned before, many times professional grade scanners will be able to scan these types of surfaces much better because they are made different. The good news is that most cars have a healthy coat of road dirt all over them, and this helps the scanner see them without the need to apply any powder or other material to increase the reflectability. So as a recap, if you are aware and prepared on how to handle challenging surfaces like highly reflective surfaces and very dark non-reflective colors, you should be well equipped to tackle just about any project.